Okay, we're going to go through, this is section 4.1c of your guided notes. It covers multiplying radicals. So thus far we talked about naming them, we talked about adding and subtracting them. Today we're going to talk about multiplying them. And then in the next video, it will be the very end of these notes that we'll talk about dividing them. So really quick, I'm going to build off of what we just finished with our last one. So we talked about adding and subtracting. What we always do is we simplify each radical as much as possible, right? And then we combine them by adding or subtracting their coefficients. And remember to add or subtract like terms. They had to be like radicals. So they had to have the same radicand and the same index. On this last example we had, right, we had a square root of 2 and a square root of 3. So those couldn't combine. We just had two terms left in our simplified radical. Now, notice just like when you're adding like terms in polynomials, think about the difference when you're multiplying. Notice that when you multiply or like distribute, right, through multiplication, when we did this with polynomials, we multiplied the two front numbers, so this would be like 6, and then x times x squared was x cubed. Now when you add like terms, let me just put an example here so you know what I'm talking about. If we had like 2x cubed plus 7x minus 3x squared plus 10x cubed. In this case, when you're adding like terms, you have to find the ones that have identical variable parts and exponents. But notice when we multiply, that's fine that they don't. We just distribute it through, right? We get x to the third. We multiply here. We multiply the 2 times the negative 2 and get negative 4. We have an x times y, that would be like 4xy. So same thing when you're multiplying radicals. The only thing, we just have to make sure that they have the same index. So you'll notice these two down here. This one's a square root. Look at that little index that's not written, right? That means it's a square root and a square root. So we can multiply them just like we did up there. You multiply the coefficients together, so 2 times 3 is 6. Then you multiply the radicands. So this would be like the square root of 60, 6 times 10. And then just at the end, before you're done, you do need to simplify that if you can. So 6 and 10, just like our last videos, we get 2 and 5. 6 would be 3 and 2, so we use those two. It's a square root, so we need a group of size 2, so there's two 2's there. So this 2, right, comes out front and multiplies by the coefficient that's already out there, so we get 12 in the front. And then on the inside, you have that leftover 3 and a leftover 5. So 3 times 5, we put 15 back in. So that's how we multiply. Okay, they don't have to be like radicals when you multiply. They just have to have the same index. So I wrote that in the wrong spot, but they need to have the same index, okay? So there's another example there, but I'm going to jump over into 4.1c. So when you're multiplying, again, the steps there is you multiply the coefficients together. So just like when you multiply like terms, we multiply the coefficients and then we multiply the radicands. Okay, you do not multiply the index. Index stays the same. If there's no coefficient, remember the coefficient is a 1, right? So you do have like a 1 there. And then in the end, you can simplify the radical. Technically, you could simplify it first if you wanted to, which is why I wrote step 0. But sometimes after you multiply, you need to simplify even more. So then you have to simplify again. So it just completely depends on what you prefer. So let's use these steps. Again, jumping down just like the last example that I did. Here, we just check that this is a square root. This is a square root because no index is written there. So we can go ahead and multiply these together. So I do 3 times 2, I get 6. I multiply 21 times 12, I get 252. Now I do need to simplify as much as possible. So I'm going to create this tree. Now the cool thing about once you're creating this tree is you just multiplied 21 times 12. So I actually know that this is 21 times 12, right? I can use those big numbers to get me started. That would be like 3 and 7. The 12 would be 3 and 4, and 2 and 2 that multiply. So we're looking for groups of size 2, so there's one. We also have 3's, and then it looks like the 7 is our leftover. So we'll have a 7 inside when we're done. So again, we pull a 3 out and a 2, and you already have the 6. So if I multiply that by 3, I get 18. Multiply that by 2, we get 36. So 36 in the front, and then that 7 left over on the inside. Okay. Again, looking at the next one, we've got 2 cube roots here. So again, just check that your index is the same. We multiply the coefficients, we get 18. Once we do that, we multiply the radicands. So we get cube root of 9 times 24 is going to give us 216. N squared times n is n cubed. So when I start to break this one down, again, if I want to use that 9 and 24, I know that I just multiplied that to get 216. And it looks like we have 3 n's here. So we're going to make a group of n's. Let's keep breaking down these numerical values. 3 and 8, 2 and 4, 2 and 2. Looks like everything's going to be in a group. So we need groups of size 3. So there's a group. There's a group. All of these numbers were broken down. So looks like everything's in a group. So we're going to pull out a 3. We'll multiply the 18 by 3 as well as by 2. So 18 times 3 is 54, times 2 is 108. And then we pull out a group of n's, so it's just 108n. Okay. On part C, you'll notice that this one right here, the 5 here doesn't have a radical with them. That's fine. It's just like saying there's a square root of 1 there, right? The radicands, it doesn't really matter. We just multiply coefficients. So we get 20, cube root of 16. And then we simplify as much as possible. So that would be 4 and 4, 2 and 2, 2 and 2. So we have a group of 2's there because this was a cube root. That comes out and multiplies by the 20, which gives us 40. And then we have the cube root of that leftover 2 there. Goes back inside. Okay, D is another example where this time instead of not having a radicand or a radical, it looks like there's not a coefficient. But remember, if there's not anything written there, the coefficient is 1. So we essentially do 1 times 3, our coefficient. So we get 3. And then you have 15 times 4. So in this case, it looks like we have the square root of 60. If we go ahead and break that down, we have 6 and 10. I feel like we just did this on one of the previous problems. We have a 2 or group of 2's here, right? The 2 comes out front with the 3. So 3 times 2 is 6. And then we have the square root of our leftovers, 3 and 5. So we multiply 3 times 5 is 15. It goes back inside the radical. Now, again, you can simplify initially. So if I were to look at this, let's look at this one. I'm going to rewrite it over here. Square root of 15 times 3 square root of 4. The 15 doesn't actually break down any further than 5 and 3. So I know that that's as simplified as it can go. But we know that the square root of 4 is 2, right? This is like 2 times 2. So this is really the same thing as the square root of 15. And then we have 3 times the 2. So that's like 6 times square root of 15. Or in other words, exactly what we wrote. 6 square root of 15. Oh, I wrote a 16. Oh, I don't know what happened. Sorry about that. Okay, sorry, that's a 15. Okay. There's some more examples down here, so I would suggest trying a few of them and then checking it with the guided notes key that's been posted. Okay. Let's jump down to using the distribution property. So the distribution property works just as it always has. And you just have to remember coefficients multiply together and radicands. You can only do 2 terms at a time, right? So when I jump down here, I'm distributing this radical term and multiplying it by the 4. So notice that you have your coefficients 3 and 4. That would give me 12 when I multiply them. Then I have a radical and I have no radical. So that just means it's the square root of 5. That guy didn't change at all. Okay. Now I ignore the 4 because I already multiplied to the 4, and I'm going to distribute over here. So once again, I take the 3. the coefficient, multiply it by its coefficient, so 3 times 2 is 6, and then I multiply the radicand, so 5 times 4 is the square root of 20. Then if we can, this is like adding what we did on the last assignment, so we have 20, oh, that's not effective. Maybe we have 2 times 10, 2 times 5, that would give me this group of 2's, that's great. So out front I have 12 root of 5 already. This 2 gets to come out and multiply by the 6, so that gives me 12, and then I have square root of that leftover 5. So it looks like now we have square root of 5 and square root of 5, we can add those together, so 12 plus 12 would be 24 square roots of 5. Okay, let's do one more. Distributing here, again, we do this radical term times the first term, so you're only looking at these two pieces first. So we do the 2 times the 4 and we end up with 8. Then we do the 7, which is inside, times the 3, which is inside, to get 21. Okay, once I'm done with that one, then I look at the next two pieces. So if I distribute over here, I'm now looking at that one and the second piece. Now remember, again, it's like there's a 1 there. So we've got -1 times 2 is -2 times the square root of 7 times 7, which is 49. Then we simplify if we can. Now the nice thing is we just multiplied 7 and 7, so we know that this is a 7, right? The 7 comes out to multiply by the -2, and if there's nothing left, we don't need the radical. 21 breaks down to 3 and 7 with no groups, which means it has to stay inside. It can't simplify. So this would be our final simplified piece. Now they can get larger as far as like foiling, so notice here. But again, they don't get any more challenging than that. It's still the properties that we've always used. So there's another distribution one if you want to try it. Let's jump over here to number 6 and try this one. So remember, when we're foiling, we take this first term and we multiply it by each piece over here first, right? So we do the first 2. Again, 7 times, let's remember there's like a 1 here. 7 times 1 is 7. Then we do the radicand, so 2 times 2 inside the square root would give us the square root of 4. Okay, now that I'm done with distributing to that one, I distribute to the second one. So I have 1 times -5 is -5. There is no square root by the 5, so it gets to stay the square root of 2. Okay. Once you're done with that, now we take the second piece and distribute him to both terms. So you've got -5 times 7 is -35. And again, he doesn't have a square root, but this one does, so the square root comes with. Then at the end, you just have -5 times -5, which is +25. So you have all 4 terms, and we just need to go through and simplify what we can, combine terms if we can. So if I simplify this one, right, square root of 4 is 2. So that's just 7 times 2, which is 14. These both have square roots of 2. So I can do -5 minus 35 is -40, square root of 2. And on the right-hand side, I have a +25 still. So now you have this 14 that can combine with this 25. And we end up with 39 minus 40 square root of 2. Okay. That's as challenging as they can get. I'll do one more using the box method, but essentially that's what we're looking for here. So I'm going to jump to number 8. Those of you that like the box, or you just want to organize it in a box so you don't lose your radicals. Again, remember, we do 2 square root of 3. That's one term or one piece, and we would do 6. And then we do the other binomial across the top. Once we have that, then we go ahead and we multiply. So if I'm multiplying 2 root 3 times the square root of 5, again, we remember there's like a 1 here, so 1 times the 2, that would give me 2, and then 5 times 3 is 15 on the inside. 2 square root 3 times -4, so remember we multiply the 2 times the -4 to get -8, and this guy has a square root of 3, so it has to come along. All right, then we're moving to square root of 5 times 6. Well, 6 is on the outside, right? Square root of 5. Perfect. And 6 times -4 would give me -24. Notice this one doesn't have any like radicals. You've got a square root of 15 that doesn't even simplify because that would be 3 and 5. No groups. You have a square root of 3 and you have a square root of 5. So all we would do is we would pull these out. It doesn't matter what order you put them in. We're not going to talk about a standard form per se in relation to our radicals. So this one just has those final 4 terms. Okay, that's it for this one. I'm going to build another video to talk about dividing radicals. So click on the next one to go